everybody and welcome back to another video. In this video, I will be teaching you U-Substitution. Now, this is a unit that you are probably getting to right now if you are an AP Calculus AB, and a unit that you might need a little bit of help for if you are an AP Calculus BC, so that is what I'm here to do. So let's begin by trying to integrate this problem right here. So as you can see, we have x multiplied by sine of x squared. So let's start off by letting u equal to this x squared on the inside. So that u is equal to x squared. Now we are going to differentiate both sides of this equation with respect to x. So through implicit differentiation on this left side, we get du over dx is equal to the derivative of x squared with respect to x, which we know to be 2x. Now, this is a first order derivative, so it can be treated as a fraction. So let's multiply the dx on both sides, and we get that du is equal to 2x times dx. So let's divide this side by 2x. And this gives us a statement that du over 2x is equal to dx. So now, as you can see, we have an x on the outside and x squared on the inside. So we will be plugging in our dx, we will be plugging in du over 2x, and for our u, we will just be plugging in x squared. Or for x squared, we will just be plugging in u. So this becomes the integral of x times sine of u, and then we will replace this dx with du over 2x. So this is du over 2x. Now these x's cancel, and we can bring this 1/2 on the outside, and then that 2 goes away. So we get 1/2 the integral of sine of u with respect to u, and the integral of sine with respect of sine of a variable with respect to that variable is just negative cosine of that variable. So that's negative cosine of u plus c. And this is 1/2, since we have to bring down the 1/2. And now, if you recall, u is equal to x squared, so we can just replug that in right here. So this becomes negative 1/2 cosine x squared plus c. And this is our answer for that first integral. So, as you can see, we had something on the inside of a function, and we had the derivative of that, or a form of it, on the outside of the function. So we had to get the derivative of this out here by setting that equal to u and then being a du by dx statement. So now let's try this one. This one's a little bit harder. So if you remember from your algebra 2 or trigonometry class, tangent of theta is equal to sine theta divided by cosine theta. Now let's rewrite that into our integral. So let's divide these sides first off. It becomes sine of x over cosine of x dx. Now, look at this bottom term. So the derivative of cosine is going to be negative sine. So we want that to cancel out the one on the top. Now we are not going to set u equal to sine, because then we would get a divided by cosine, and this would become u divided by cosine squared of x, and we have an x in a du statement, which does not work. So we will be setting the bottom as our u. So u is equal to cosine x, differentiate both sides with respect to x, and you get du by dx through implicit differentiation is equal to negative sine of x. Now, this is a fraction, so it can be treated as a fraction, as it is a first order derivative. So this is times dx, dx is cancel, and we get du is equal to negative sine of x dx. We want dx by itself, so we can plug it just in right there. And we just divide both sides by negative sine of x. So du divided by negative sine of x is equal to dx. Now, let's plug that in. I'll make that more of an x. So now let's plug in our u's and our du. So u is equal to cosine x, so this is sine of x still on top, divided by u. And now we are going to be replacing our dx with du by divided by negative sine of x. So this is du over negative sine of x. If this cancels with this, the negative gets pulled to the outside. This becomes positive since there's now a negative on the outside. And this is negative integral of 1 over u du. And the integral of 1 over a variable with respect to that variable, well, that's just the ln of absolute value of that variable plus c. I just carried down that negative. So we remember that that variable was just cosine x. So this becomes negative ln of the absolute value of cosine x plus c. Now this is an answer, but I don't really like this negative out here. And through logarithm rules, since we have that negative log of a is equal to the logarithm, or the natural log, or any log base of 1 over a, we will just use that rule, and this becomes ln of 1 over cosine, which is just secant x with respect to x. And this is our answer. So, I hope you all enjoyed this video. And understand this topic a lot. I really like U-substitution as it becomes more and more intuitive as you do it of what your U becomes. And this is a subject that you really just need to practice a lot. So let me know if you want me to make another video on this subject. So please like and subscribe if you enjoyed, and thanks for watching.